So May-June 2017 paper. Usually the first question is about identification. First two questions are related to identification of the ions. So we have the ore. Malachite is a green mineral which has been widely used to make jewelry and decorative objects. And the formula is given. Give two observations that you would expect to make when a sample of malachite is heated in a boiling tube. So what are the two observations? As you can see here, it is like copper 1 carbonate is there. It will become copper oxide. So copper 1 carbonate have different color as compared to copper oxide. So there will be a color change. As initially it was copper 1 carbonate and it turned into copper oxide. So there will be a color change or it will form a black solid. And the second thing you can see, the water is also like given off, and we are supplying heat energy temperatures above 300. So it won't produce water in a liquid state. It will produce water vapors. So we can say a color change, produce a black solid because copper oxide is black. And the second thing, it will increase the produce water vapors or misty fumes, you can say. Sorry. Or a gas is given off. Describe a chemical test that you would use to show that the water is formed and give a positive result. So how we can check the presence of a water, a chemical test? We can use anhydrous. We can use anhydrous copper 2 sulfate. It will or cobalt chloride paper because gas is there. So usually cobalt chloride paper is more like suitable rather than copper. So we can use a cobalt chloride paper and it will turn from blue to pink. As the water vapors are there, that's why if it was test for a water itself, then copper sulfate is acceptable, but practically here, as the water vapors are there, so cobalt chloride paper. Describe a chemical test that you could use to show that the carbon dioxide and give a positive result. So we'll test pass through a lime water, it will turn milky, turn cloudy or milky. Give two observations that you would expect to make when dilute sulfuric acid is added to a sample of a powder in a malachite. So it is actually a carbonate. So copper 1 carbonate is there. If you add sulfuric acid or any acid, it will give salt, water, and carbon dioxide. So there will be phase bubbles and effervescence will be there, and, and a copper sulfate solution will form. So as a result, it will form a colored solution. So fizz, bubbles, and it will form a colored solution. That colored solution is due to formation of copper sulfate. Then write equation. So malachite formula Cu, copper 1 carbonate and copper, it's like copper 1 carbonate and copper 2 hydroxide mixture. So it is Cu to CO3 dot or OH2, that is, and we add sulfuric acid. So Cu2, CO3 plus sulfuric acid, H2SO4. So it will form copper because like acid react with carbonate, like if nitric acid, the copper nitrate will be there. Sulfuric acid, copper sulfate solution will be there. So CuSO4 plus salt, water, and carbon dioxide, CO2. Then balancing is there. Start balancing with oxygen followed by hydrogen and then other. Copper 2, so if I put 2, copper is balanced. Hydrogen 2, and oxygen 3 plus 7, and I have like more oxygen. So if I put 2 here, because 4 multiplied 8, 9, 10, 11. 4 multiplied 8, 9, 10, 11. Oxygen is balanced and hydrogen is also balanced. So this equation, and hydrogen is not balanced. 2 multiplied by 2, 4. And okay, I missed that copper 2 carbonate should be, the malachite is copper 1 carbonate dot or a bracket OH2. And this will be 3 here. The next is when reaction of a dilute sulfuric acid was complete, a solution of a compound M was added the reaction until no further change. A final solution was a deep blue. So copper compounds, when it give a, because if it was sodium, aqueous sodium hydroxide was added, it will form a blue precipitate which will remain insoluble. So identify what we add. It means we add aqueous ammonia. Because when aqueous ammonia is added, it will first form blue precipitate, which will dissolve to form a deep blue solution. The apparatus, the apparatus below was used to confirm the formula of a sample. So solid X absorbed water and solid Y absorbed carbon dioxide and heated until the decomposition was complete. Suggest a suitable substance X. So which substance can absorb X? So it should be like um, drying agent. We have, because drying agents have a capability to absorb the moisture. So what are common drying agent which we use? We use anhydrous cobalt, calcium chloride or sodium sulfate, or calcium sulfate is also right. So usually anhydrous calcium sulfate or sodium sulfate or calcium chloride. Substance Y should be a basic substance because it is absorbing carbon dioxide. Carbon dioxide is a non-metal oxide, and non-metal oxides are acidic oxide. So you can have pellets of sodium or potassium hydroxide here, or any hydroxide. So this solid Y should be either calcium hydroxide, potassium hydroxide, sodium hydroxide, because acidic gas can react with an alkali. How would you show that the decomposition was complete? So how we can identify that there is no more further decomposition happening? Usually, whenever we want to make sure that the thermal decomposition is complete, we heat to constant mass. What does it mean? We heat to constant mass? Like we heat for 2 minutes and then we measure the mass after 2 minutes. Then we heat again for further 2 minutes and then measure the mass. Maybe it was 1.8. Then we measure the heat for 2 minutes and then measure the mass, maybe 1.6. And then after it is 1.6. We will heat until the mass is constant. So how we make sure that all of has thermally decomposed, that's a common technique. So we heat until the mass does not change or heat till the constant mass. So here answer, heat till the constant mass or mass does not change. State the measurement that you make to carry out this experiment to confirm the formula. So how we can work out what might be the formula of this malachite? Uh, what actually like we can do, we can use like measure the mass of a sample in the beginning, and we can measure the mass of a residue and then find their moles, because the balance equation for thermal decomposition. So what we do, We measure the mass of original sample. We measure the mass of original sample, and then we measure the mass of a residue. And we compare these two, like we compare the mole ratio, like find the moles of the original and moles of the residue. If the ratio is 1 is to 2, it means that the formula of a malachite, which we write here, is correct. Is it clear, this one? The next question is related to identification of the organic compounds. As you can see, 3 different compounds are there. One of them is aldehyde. How we can test an aldehyde? One is a ketone, and like a ketone, second is ketone, third is also ketone. But how we can distinguish when a methyl group next to carbonyl group? So we can use the iodine test to identify that. Here aldehyde is, this is an aldehyde, and this is also ketone. So each of these compound was subjected to 3 chemical tests. 2,4-dinitrophenyl hydrogen. Iodoform test is there. Sorry, iodoform test. Toluene reagent is there, and 2,4-dinitrophenyl. So all of them, because all of them are carbonyl group. So if we do 2,4-dinitrophenyl hydrogen, tick here refers to, like, it will give a positive result, like it will give a orange or yellow precipitate, red or orange precipitate, all of them, because they are all carbonyl. Toluene reagent, it is only valid for aldehyde. It will be oxidized. Ketones cannot be oxidized. So this will, you don't have to put a tick, you have to state the observation. Like, what will the observation here? It will be it will form a shiny solid or a silver mirror layer, and here there will be no reaction, and this also there will be no reaction. Iodoform, when methyl group next to carbonyl group is there, a neighbor. So this won't give a result, this will give a result, this won't give a result. But you have to mention, and in iodoform, what is the observation? Yellow precipitate is there, and a smell, antiseptic smell. Then name the reagent that are required for the iodoform test and describe the procedure to carry out this test. So you have to write how this test can be done. We usually, what we use a aqueous iodine solution is there in like mainly iodine in potassium iodide is there, and we use sodium hydroxide or potassium hydroxide. So iodine solution in aqueous potassium iodide, they are mixed with each other. And what we do, we add alkali to iodine until a brown solution turn colorless. And then, like, first we add iodine to, or add alkali to iodine solution. And this iodine solution is this whole. So we add alkali to iodine solution until brown solution will turn. Like originally is a brown solution, it will turn colorless. And then we want, or we can heat in a water bath, and it will give us specific colors are given. Like usually for iodoform, it gives a yellow precipitate is there. So add alkali to iodine solution until the brown solution turn colorless, and then this thing is added to or mix with a substance, organic substance, and as a result it will form a yellow precipitate. Then one of the structure in the table circle the proton environment each molecule, and so we have to identify how many environments are there in each of them and different number of proton each molecule. So for the first one, how many proton environments are there? When you See, like this is hydrogen CH3, CH2, CH2, but they all are different from each other. And here it's CH is there. So they all are different from each other. So this will be 1, 2, 3, 4, and there's also hydrogen 5. So number of hydrogen environments will be 5 here. When we check for this one, so 1, 2, 3, this does not have any hydrogen, so this will be 4. So 4 hydrogen. And this is 1, 2, and this will be 1, 2 because they are identical, like 1, then identical this also. So 1, 2, 1, 2. So actually there are 2 hydrogen environments. Is it a clear discussion?